Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. And on today's episode, we've got a actually really interesting show. So first thing we're going to cover today is new lawsuit from Siemens Gamesa, kind of firing back at GE over their Haliade X offshore wind turbines. So we'll talk about some of that. We've had a bunch of litigation, it seems like, recently in the news. So we'll talk about Siemens Gamesa versus GE. We've had a really interesting, strange, bizarre lightning season here in the US and really all over the world. So we're going to chat a little bit about that. Of course, so one aspect of it is that, we have fewer lightning fatalities than ever, in part because of COVID, but yet we also have just a terrible fire season from lightning. So we'll chat there. And then our engineering segment, we're going to talk about ducted wind turbines. So this is a new idea in small wind turbines. And obviously this is one of the big things in EVTOLs, which we talk about in the Struck podcast, our aerospace engineering podcast. And so ducted fan technology has been around for a while, but does this work for little wind turbines, and will it potentially work for bigger ones? We're also going to talk about a snafu with a semi-truck pulling a wind turbine blade, and just some of the transportation issues in general. And then lastly, wind turbine fires, which don't seem to get too much publicity, but are going to become more and more of probably an insurable event, or something that people are going to want to be insured against going forward as these turbines continue to get bigger. So Alan, let's start with Siemens Gamesa suing GE. They're back in the ring again. So it looks like they're suing GE potentially a little bit because they're upset that, and this is what GE was claiming, that this is just a countersuit. They're just upset that we are trying to block them from being in the U.S. market over their own property, intellectual property infringement. But Siemens Gamesa says that no, your nacelles, your direct drive technology, and your Haliade X is infringing on our technology, and the way they cool their generators is infringing. So what have you got on this?
Well, I think both of those things can be true, that one is infringed on the other and vice versa. That can always be true. I think the question is really what drives all this, and market factors tend to drive lawsuits to one company to another. If everybody's making plenty of cash and they're having great sales, they don't really think about suing the other guy unless it's just egregious. But in this particular case, because COVID's hit and things have slowed down and there's really no quick ending in sight, you start to feel that cash crunch, and both GE and Siemens Gamesa are in that cash crunch category. Then you start really trying to protect what you have. And that's what it seems like right now. We just got this sort of mortal combat going on, and trying to each one protect their own territory. It makes sense, but the only groups that get rich out of this are the attorneys. That tends to be what happens. I don't think there's going to be any, here's the thing. You see these articles go back and forth saying Siemens Gamesa did this and GE did that. But when it all settles out, it'll be pretty quiet. You really won't hear anything. It's probably negotiated in a back room somewhere. And if they get smart, they'll just say, hey, peace, and let's figure out how to make this work. And everybody just get back to making wind turbines, which is what they should be doing. But I just think that right now, just because everybody is in a cash crunch, these kind of things tend to pop up more often.
So the U.S. might see the fewest lightning fatalities on record this year. Can you tell us a little bit about why the Washington Post is reporting that?
Well, it is unique because as the country, there's more people every year. Obviously, there's more people. I think in terms of population, I think we have roughly in the United States about 2 million immigrants into the country per year, at least in the last several years, plus the birth rate and all those things that play into it. So there's just a larger and larger
300,
population. Yeah. So we're like
331 today. It sounds like.
There you go. Right. So and we tend to spend a good bit of time outdoors, and there's been at least a fairly recent push to get outdoors, particularly with COVID, to get outdoors and to do things outside of groups.
Nothing else to do. Yeah.
Right. Mm-hmm. So you'd think that the camping and there's a big push to go out camping and do all those things and just to get outside just to maintain your sanity. You think that the lightning strike deaths will actually jump because people are spending more time outdoors, but it had actually gone down a lot.
Yeah, it's counterintuitive. You're right.
It is, right? So either we're spending a lot more time indoors, which I don't think is probably true, or there has been a substantial decrease in the number of lightning strikes. And I think that's probably more the case, that the lightning strike frequency has dropped in combination with the amount of fossil fuels that are being burned, the factories that are running, the amount of heat in the atmosphere. All those different things are changing, and it's when you have substantial changes in the atmospheric properties, that kind of falls out a lot of times in terms of lightning strikes. So it's not. I don't think it's unusual to see the lightning strike decrease, the number of lightning strikes decrease. I just wouldn't think necessarily it would drop down to the lowest recorded levels of lightning deaths. I mean, it's super that there's extremely low, but we need to be studying the other side of it. Right, Dan, don't you think that it's the lightning deaths, and maybe that's just the way people are behaving. There's a little more, maybe everyone's a little more cautious. Maybe that's part of it too. Taking less risk right now.
Yeah, I can't think of like a great reason, considering you're right. A lot more people are not in the bars; they're out in the park.
Right.
So you'd think they'd go together, but they're not.
They're not.
So, I mean, is the density of lightning strikes increase or decrease? Or, I mean, I know we talked about this before.
It takes time,
but
you have to measure it when it's over. It's hard to tell when you're in the middle of it, right? You have to kind of get all the lightning seasons data together and then go back and start comparing to previous years, and particularly with the lightning density maps that happen. You have to be careful how you look at that data. So hopefully by December, January, when things settle down in the United States, that we can go back and take a look and see what's going on, because it may have broader implications to how we run things in the country, and maybe also how we deal with lightning strikes and keeping people safe. That maybe there's something that we've done recently that's changed all that. We need to figure that out.
Well, so speaking of lightning, there were nearly 14,000 strikes over a 3-day period in August, and that is pretty much the ignition source of about 900 wildfires that are going on in Northern California. So why is it, if all the deaths are lower, why is this happening?
Well, having been to Northern California a couple times recently, it's funny because what you hear on national news is, there's been a number of lightning strikes. It's unusual to have lightning strikes, and it's causing all these fires to occur. Yes, it could be that there are more lightning strikes and it's a freak storm. Fine, that's probably true, but it wouldn't be outside the law of probability that would happen. But Northern California right now is extremely dry. Everything about it's dry. Unless it is irrigated, it is dead or near death. Grass, trees, plants, it's just this barren, burnt wasteland, and that's before the fires start. And you can see where the fires have rolled through, and I can't imagine the fire agencies can even really try to slow them down all that much, because there's so much fuel, even outside the forested, the things you see mostly are the forested area, but just the sort of the Napa Valley, which is burning right now. I drove right through the Napa Valley a month ago. Dry, and then you see vineyards that are perfectly green because they're irrigated, and dry.
Mm-hmm.
So thinking that fires are going to run through the Napa Valley, that made complete sense when I drove through it. Like, it wouldn't take all that much, but I think you have to, you think you have to sort of know that lightning strikes are going to cause fires and sort of be prepared for it on the amount of combustible material that's laying on the ground right now, and sort of be prepared for it. It isn't like this hasn't happened before in California.
Well, two things. One, how do you prepare for it? I mean, are we going to irrigate? Like, where are we going to irrigate such massive pieces of land? Like, can you really do anything about these forests where a lot of them are starting? I think
fire breaks probably is the thing. Is that they probably have some fire breaks in them, but my guess is that having advanced forestry, I'm going to say like we do on the East Coast, we don't have as dry of conditions as they have in Northern California, but there are sort of built-in fire breaks at times, just to slow things down, and it would be a huge effort to slow it down in California But
Yeah.
now you're having built-in fire breaks because the fires have ravaged so widely that you have built-in fire breaks. Eventually, it's gonna, you're gonna get to the rainy season. Some of the stuff's gonna stop, but right now it's just a disaster, big disaster.
Yeah. Well, and it seems to circle back to what we talked about in our episode with Matt Malkin and Alex Byrne, which is that we still just don't know that much about lightning.
Nope.
I mean, would you agree? It's just like we kind of understand that if it gets you, you're gonna either be down for the count or hurting, and it might set off a big chain of events. But I mean, as far as these numbers conflicting, like deaths are down, wildfires are up.
Right.
Strike frequency and density seems to be changing consistently. I mean, we talked about the Tokyo Skytree, that huge structure in Tokyo, like changes the whole like electrical environment in that area. It just seems like there's a lot we still just don't know.
Right. There's too much randomness to it, and we haven't really studied it all that much, which is a shame because in this particular case, with the number of wildfires in the hundreds of thousands of acres that have already burned in California, north and south, by the way, as most of California is on fire, that we should have some sense of the likelihood that was going to happen and do something about it. But now, obviously, it's just like human nature. Once you have the fires, then you're going to go back and fix it. So hopefully this doesn't happen. Again, we can do something on the backside. But I think we just need to be vigilant about it. On the lightning side is trying to understand what some of these effects are and why they're happening, and to give everybody a heads up of when it may occur again. That would be really helpful. But we have to be pretty vigilant on holding sort of the scientific community and the political community on the next steps. It's like when we had the hurricanes in Louisiana, where we had a hurricane, it wiped out New Orleans, and then they started to build the levees and things, but they weren't really finished. And then we had another hurricane, and it ravaged the unfinished levee system. Why are we not holding people accountable for that? I don't know. It's crazy.
Yeah. Well, and of course, it seems like buildings have been pretty well protected since Ben Franklin invented the lightning rod. I mean, we don't hear of skyscrapers going down or of a chunk of it shearing off and falling to the streets of Manhattan, which is exactly what used to happen before the lightning rod, right? Like
Yes.
like a church just got made out of wood, just gets struck and set ablaze all of a sudden,
All the time.
or a concrete structure just gets hit and a huge chunk of it slides off, or
That's
a wall
right.
goes down, right? So
That's right.
that doesn't happen anymore, which is pretty amazing. And that's why Ben Franklin was such a revered human all over the world. Like, he completely solved that problem essentially. But now that we have these, like Alex Byrne said, like, the way these things spin just is fundamentally different in the atmosphere to something that's just stationary. And so it's just crazy.
Well, it does make you wonder, if they started putting some essentially lightning strike towers or lightning rods in the forest, would it change the dynamics of the number of lightning strikes they're having? Because if you can drive that energy in the ground without causing a fire, that's a great situation. And we're only talking about
Seems like
a small copper wire was all it would take, quite honestly. It wouldn't have to be anything very complicated to do, and to try to either to attract lightning to this thing, and like you're saying, change the dynamics such that you can control or where you control where lightning strikes. You see this all the time in wind turbines. So on wind turbines, on a field of wind turbines, as the storms in the United States move from west to east, like most places in the world, not really different. And when they move west to east, the furthest west wind turbine is the one to get struck the most, just because it's the first one in line. If we did something similar like that into the forest, we could probably knock down a number of damaging lightning strikes. Absolutely.
All right, so as we move on and talk a little bit more about engineering, let's jump to ducted wind turbines. So if you don't know what a ducted wind turbine is, it's just when it has this how do we phrase this, Alan?
Circle?
Cone? Without using, because I learned in elementary school, you never use the word in the definition. So it's just got a shield around. Yeah. So it's got a circle around the circumference of the blades.
Yeah.
Yep. And it just what is the aerodynamic property of the duct?
It helps focus the airflow, and there's some tricks you can play with ducted fans on increasing airflow through the fan, the way you shape those ducts. So you can get increased efficiency or more power generated by a set of rotating blades. On the opposite side, on the aircraft side, you use it to increase the thrust, right? But it comes with other drawbacks. But in a stationary thing, like a wind turbine, if you can reduct the air and force that air into the power generating blades, you will increase the efficiency of the system. Thereby, you could, I think that the thought process is that you could use a constrained size blades but have more power out of it. So the compromise is that if you didn't have that ring, you would have bigger blades, which makes it harder to put the wind turbine up in a tight location, like on top of a building. So you can actually have a smaller system with more power generation, which is exactly what you would want, right? It just adds a little more difficulty on the engineering side to do that, because if you can imagine, if you had 100-meter long blades, if you wanted to put a ring around it, it gets a little tricky.
It's pretty big. Yeah, I got to start using 3.14159 times whatever. It gets real complex. Got to break out your gravity calculator.
Right.
But I mean, so they don't have these on propellers of airplanes. Why? Why is it not on the front of an airplane?
They sort of do. Well, they don't on traditional propeller airplanes. They don't, but I mean, all the sort of NASA studies back in the 80s, and you see a lot of it on the electric vertical takeoff and landing aircraft today. The first proposed designs are always these ducted, quote unquote, ducted fans, so that they can get more thrust out of them. The problem is that on an airplane, you have to fly with those ducts all the time, which is a negative aerodynamic consequence of having the ducts. But on a wind turbine,
oh, gotcha,
doesn't really matter because it's pretty much stationary, right? It's always pointed into the wind. So you can do that. I think the concept is really interesting. I haven't seen a lot of traction on it yet, because at least in the Northeast United States, a lot of times there's restrictions on wind turbines, particularly quote unquote personal wind turbines. And in a lot of towns, they're prohibited. So only the big, gigantic 2-megawatt machines on top of the mountains are allowed. The smaller ones you would typically see on a farm in the Midwest are not allowed, which is bizarre, but whatever. But if we can get more efficiency out of it, those places like in the Midwest that would normally use them for generate power for a pump somewhere, it make a lot of sense to increase the power generation capability of one of these things.
Yeah, and so on the ducted wind turbine company, ductedwind.com, they claim that it makes about twice the energy of a turbine the same size. So with conventional open blade design. Now, for lightning implications, could you just make that ring out of metal and just like that's your LPS now all of a sudden? I mean, it seems like it's kind of protecting the rest of it, right?
Yeah, they won't want to make it out of metal because that's hard
and heavy. Yeah.
Well, no, it's not as heavy as fiberglass. What they want to do is make it out of the lowest cost material they could probably make it out of, and the stiffest material they can make it. So that usually ends up being some sort of composite, most likely fiberglass. And if lightning's going to hit this thing, it's going to hit the duct. It's where it's going to hit. It's the outermost part of it, and so it makes sense to put some sort of lightning protection on that duct, whether it be just some copper wire wrapped around it, or some could we use on aircraft metallic expanded foils on it, or even just put a lightning rod above it to attract it away from the duct. Any of those would work. But you'd want to do something there, because if that duct gets damaged, next thing it's going to do, it's going to move or break or run into one of those blades, and then you have a much larger problem. If the duct gets damaged, so what? It's the consequence of the duct getting damaged and then smacking into one of the blades, and then who knows what the consequence of that is.
Yeah, well, and also as I looked at this, I mean, how close do the tips of the blades have to be to the inner edge of the duct for it to be effective aerodynamically? Because that, to me, seems like, okay, this is up there for 20 years or 10 years or whatever, and one day the wind's really crazy and it's flexing a little bit in a big wind and it starts to nick the blade. Does the whole thing just get just ripped to shreds by its own power?
Could, based on speed and the wind at that particular time. It could. The separation between, I'm going to talk aerodynamics for a second, but I don't want to get too deep into this, but essentially it kind of goes like this. The ducted fans, all that, there are certain parameters about spacing between the duct and the fans, and the curvature of all of it, and how much weight it is, right? So there's a bunch of trade-offs on how much duct there is versus how much blade there is, and what the shapes of the blades are, and how air is moving. That's where computational Aerodynamics has made a huge stride, and this is why these things are possible, is because we can do it on a computer, don't have to make it in real world. But it depends. It really depends. So the gap between the blade and the ring, so to speak, is variable depending on what you're trying to accomplish. So yeah, I think you're right. I mean, if that ring starts to sag or starts to get, there's any sort of vibration and that ring smacks into a blade, that's bad day. Really bad day.
Adios, wind turbine.
Right.
All right, moving on. This is a pretty funny story out of Minnesota. So, a semi-truck driver carrying a 250-foot long wind turbine blade somehow missed his turn in this downtown area and got trapped. So he missed the truck bypass, got stuck in this small town in Minnesota. And Alan, do you know what his solution was? He had to back up for about a mile. They said about a pedestrian's pace, and just like walking like 3 miles per hour,
man,
to finally get where he could get on this bypass and then get back onto the road. But that just sounds like an absolute nightmare.
There goes the afternoon right there.
Yikes.
That's bad.
I mean, when's the last time you had to back down something?
A
like
mile?
You get stuck in an alley or just any distance.
Oh, well, it actually happened the other day. Kind of went wrong way down the street, ended up backing out of it, but it wasn't very far. It wasn't a mile, maybe 100 feet. Like, going the wrong way. Let's go back.
Okay, so it's a regular occurrence. So this really hits home to you. Got it.
Yeah.
Got it.
But I wouldn't say. See, but the thing about this when they're moving these wind turbines is that because it's such a wide load and a long load, that they kind of check two boxes, and that they usually have a driver that's in front of the tractor trailer that directs where to go, and in front of them is a state patrol officer. There's a state patrol officer in the front and the back usually when you see these caravans going down the road. So somebody in the front did not take the right turn, and my guess is that the tractor trailer was just following, that they just followed the leader and got down into town like, whoa, we're going to start knocking down street lights and knocking down power lines with this blade that's behind me, or hitting buildings because I can't turn the corner, which is probably what they're going to knock down the 7-Eleven when he makes that left turn. And so the only thing you do is to back out. And man alive, that takes a lot of driving skill to do that. I don't know how they find these drivers, honestly, because you really have to know how to drive. Particularly now you're putting this thing in reverse. It weighs a tremendous amount. You got this trailer way in the back of you. You really can't see what's going on. And now you've stopped all traffic, and I'm sure people are honking the whole thing. That now that reporters are coming out taking pictures of you, you're just thinking, man, I need to get out of here. And you're going to be sitting there, well, at 3 miles an hour. It must have taken them 20 minutes to get back out of there. Oh man, what an afternoon, huh?
Yeah, it reminds me of, so Baltimore had a blizzard when I was living there. Those are I think the first year after I graduated from college, and it was so much snow, like 2 feet in the span of like 2 weeks or something, where just you couldn't put it anywhere. So a lot of these really long, like Baltimore, neighborhood roads with just row home.
Yeah.
You would get, so I remember this one time I was halfway down the street and a car just met me like head to head, and we just like stared at each other angrily until one of us moved, and it wasn't the best neighborhood. So I was like, all right, I'm going to go.
Right.
And I backed up like, it took me like 4 minutes to back out of this because they're all just one lane, because everywhere you park was just packed with snow.
Yep.
And that was only a couple 100 feet backup. It was long. It was a long backup by anyone's standards, but certainly not a mile like this with a huge wind turbine blade in it. So my heart goes out to this man.
Yeah, because of course he's in the guy that gets his picture taken is the one driving in the tractor trailer, not the guy in the lead vehicle, right? So the guy in the tractor trailer is like, huh? I was just following the guy in front of me. What do I have to do with it, right? But his face in the paper and on the news and everything else. Yeah, but I think that those tractor trailer drivers are sort of a special breed. That is not an easy job to do. It takes a lot of skill and coordination, and You got to tip your hat to those guys.
Yeah, so our last topic for today, so interesting article on windpowerengineering.com about wind turbine fires and some of the protection systems that are available to do that or to take care of those big turbines. But it doesn't sound like these are very often installed. That's what I gathered from reading it.
Yeah.
But it's potentially a growing problem and also something that is going to make more sense to just go ahead and install as these things get more and more expensive. So, I mean, where do you find the tipping point is on between, we don't really need that, to, well, this probably makes financial sense?
It's a cost benefit analysis. It always is. And when the cost becomes sort of inconsequential, or when the cost and the risks, start to outweigh one another, that's when you get somebody to decide on when to put the system in. So as the argument's made sort of like this, because it happens on Lightning, it's the same argument for a lot of different things on wind turbines. As wind turbines get bigger, and it's roughly $1 million per megawatt, so a 12 megawatt machine is roughly $12 million. The relative cost of everything else drops way down. All the little systems that going to be added onto it, like a lightning protection system, fire suppression system, other monitoring systems that can go on the wind turbines, get relatively inexpensive. And at that point, it's like, well, it doesn't really make any difference, because in the $12 million you're going to spend on this thing, I'm going to put another $50,000 to make it last longer. So the risk reward starts to play off, and that's when people start to make better decisions. But the fire thing is weird, because the number of fires you see in a year is relatively high. I think that you see pictures all the time of turbines catching fire. Now, the degree of how far that fire burns, the ones you really see a lot of are the ones where the hole in the cell's burned and the blades are on fire and the whole thing collapses to the ground. That's bad stuff. So what causes those fires? Most likely gearboxes or some sort of electrical fire up in the turbine. That's where that's going to happen. But we haven't seen a lot of fire suppression systems, or really, I think they have fire alarm systems. I think that happens. But what are you going to do if once it's on fire? Yeah. How are you going to get water?
Get the buckets. Get the buckets, guys.
Right. Yeah. Most of these wind turbines are out in rural areas, and they just don't have the equipment to spray water that high. Not like they would even matter. So they just kind of let it burn out, is what it looks like. Just stay away from it, let it burn to the ground, and start over.
Well, and it's, you'd imagine that as it starts to burn at all, at what point you're like, probably just a total loss. I mean, this is what they do with, you spill some water in your laptop. They're not going to go in and like try to figure out all the little. They're just be like, nope, total loss. See ya. You
right.
Getting even a moderate fender bender today, and
Cars
right off
garbage.
the car is a loss.
Yeah, it's true.
Yeah, things. I can't imagine that they would just be like, "Oh, yeah, we checked it out, and yeah, it only burned for a couple minutes, so we'll just keep it running." Like, you got to imagine everyone's like, "This was on fire for even a little bit." Like,
right.
See ya. Like, let's just replace all of it.
Big risk.
Yeah.
Little reward there. And the way to put out those fires, the only way to get it up to, because most all the fires, well, they start in two places. They start up in the nacelle where the generating equipment is, or they start the transformer down on the ground. But the only way to fight the fire in the nacelle, really, and the only way to get up there is through the tower. And there's no way it makes any reasonable sense to put some in the tower.
Who's climbing up that thing on fire?
Yeah, that makes zero sense, right? And you know how they some of the and some of these rural, well, even like in a gas station, right? In a gas, so let's just put apples to apples a little bit. And gas stations, at least on the East Coast, every single one of them has a fire suppression system. Now, whether it works or not, who knows? Hopefully we never find out. But they'll have some minimal fire suppression system in them, because that's the law. But if the gas station burnt down next to you, really, not that big of a deal, probably, because there's 5 other gas stations within 10 minutes drive, right? So we have more fire suppression in the gas station than we do in the power generation station. That doesn't seem to make sense to me quite yet. But again, it's still, wind turbines are still a relatively new industry, and when these fires occur, they're out in some rural area, and most of civilization doesn't know it's even occurred.
Yeah. Well, I guess now that I think about it, it really does seem kind of strange that they don't have these, because the only possible way to put this thing out is one of those firefighting helicopters.
Yeah. Oh yeah, and the only thing I've ever seen that's even remotely close to being able to put these out are these new drones that can carry several hundred pounds, which would be, let's just say it's 100 gallons of water. You could take a drone up there and start spraying water on it, but 100 gallons of water is probably not going to go that far if this fire's rolling pretty good.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.